Thanks for joining us on the Lake Doctor podcast. I'm Susie Light and my co-host, Dr. Nate Bosch, an official lake nerd.
Yes, that's right, Susie. I received my doctorate from the University of Michigan in limnology, which is the study of freshwater lakes. In today's episode, we're excited to have Annalieze Frentzel. She's our research lab coordinator here at the Lilly Center, and we're going to talk about some of the behind-the-scenes things that happen in our research lab with algae toxin notifications, E. coli, how we quantify and identify the algae from our local lakes. We'll talk about also how our interns are well positioned then for careers after they graduate here from Grace College's environmental science program.
I am excited about today's episode. You might even learn a little bit about lab chemistry. The doctor is in. Annalieze Frentzel, thank you so much for joining us today.
Thanks for having me.
Tell us about yourself, please.
So I am 22 years old. I started here at Grace back in 2021.
As a student?
Yes, as a student. I didn't start working full-time at the Lilly Center until this past January. So going on a year now full-time. I'm the research lab coordinator upstairs, and I have 10 wonderful student interns. It's great. I love interacting with my students. They're like the best part of my day. Every single day I get to interact with at least one or two of them, some days all of them, which is a lot of fun and a little chaotic, but it's wonderful fun.
And the ages of your interns, are they typically?
Yeah, so I have between like 20, and I do actually have someone who's 26 upstairs, so even older than I am. But yeah, all college interns.
And you're working on research on toxins.
Yes.
Yeah. Nate.
Yes.
Tell us about toxins and why are we measuring them? Why is it important to know about them?
Yeah, so algae toxins are a human health threat. They're also a health threat for pets as well. So those algae toxins can be harmful to people and their pets. And so we do notifications throughout Kosciusko County. It's interesting to note that among all the counties in the Midwestern United States, Kosciusko County leads all of those in keeping our visitors and our residents safe, because we do those toxin notifications across many of the lakes in our county. And we have a lot of lakes in our county, as we've talked about on this podcast. And so those notifications come out weekly, and people then know how to interact with the water in a safe way for their loved ones and their pets. There's collection work that happens to be able to get those notifications out. So Anna's talking about her lab research team today, and we're going to be digging into that. But we also have a field research team that's out on our lakes collecting samples that then will end up coming back to the lab. And so those field research team members are collecting water from usually the top, about 6 feet of water out in the open lake portions of our lakes, and then in about the top 3 feet of water in some of those beach areas where people are swimming in beach areas. And then that water comes together into a sample. We call that an integrated sample, and then it comes to our laboratory here on campus.
That's when Anna's work kicks in?
That sure is.
So what are you finding fascinating about doing that?
Yeah, I actually didn't start doing our toxin tests for the first time until this past summer. So going full time, I took all responsibilities in the lab. So when I was a student, I was just doing algae research. So this past summer really opened my eyes to the amount of work and time that gets put into our toxin tests, which is incredibly fascinating. There's a lot of small steps that until I started full time, I didn't realize that we had to pay such close attention to make sure that our toxin tests pass, and they pass well with good results. Upon sample receival, so when the field team drops off our samples, there are several different steps that they need to go through so that we can get our results. So the first thing that happens, so our toxin samples actually are put into a sample vial like this. We get 31 of these per week for 15 weeks during the summertime. The first thing we do is take our toxin samples and we put them in a -30 freezer, and that's called a freeze thaw. So in order for us to see the total amount of toxin in a sample, we have to break open the cells, and that's where the freezing comes in. So when we freeze the cells, it puts them under a lot of pressure, and then they lyse is the term. So they pretty much just explode, for loss of a better word here, but then that releases the potential toxin that they can release. So they go through a freeze thaw cycle 3 times. So they're frozen, and then they're thawed, and then frozen, and then thawed, and then frozen, and then thawed again. So it takes about 2-3 hours for that process to be completed. And then that's when we can move into the actual test. So one of our test kits come with a tray that looks like this. Each one of these small little wells, or what we call them, is where one of our samples go. So we can fit 27 of these samples into one of these trays.
So the tray, for those that are just listening, the tray looks like a small index card, but it has little pockets in it. And is each pocket where one toxin is?
So we test for 2 different types of toxins. They're 2 completely different tests, but for this podcast, we'll just talk about our microcystin toxins, because that's what we release every single Friday during the summertime for the public. But for each sample, we'll put 1 sample in 3 wells, and that just is ensuring that our data points are within the same boundaries. It's like a replication of the same thing to make sure we're doing it correctly. But in this process, we use multiple different what we call reagents. So we'll add our water sample into our wells, and then we'll add a reagent, and then it has to sit for about an hour and a half during an incubation period. And then we'll do the same thing with another reagent and another reagent. So from start to finish, this test takes about 4 hours. So again, a very lengthy process between this test and then the freeze thaw. We're looking at pretty much a full day's work for one test.
So you collect these on Fridays?
No, we do the collections Monday through Wednesday. Yeah. So all of our lake sampling happens Monday through Wednesday, unless we have some sort of weather issues, right?
Yes.
And maybe we can get into that in a little bit. But the typical sampling week is Monday through Wednesday, and then they do their work in the laboratory on Thursday. So that come Friday morning is when those toxin notifications go out to all of the people who have subscribed to that service.
Including the city and the parks departments.
Yes.
So Anna, one of the things that you talked about before we actually got to recording was that the excellence. You are striving for excellence.
Yes.
Tell us about that.
Yeah. So going back to our toxin test in particular, these tests are very difficult, and sometimes we just don't pass them. So based on the numbers that we receive from this test in particular. So we kind of feed it through a machine, and then the computer pops out our values for us. Based on those values, it may or may not pass. And if it doesn't pass, then we have to start back from square one. So
so it isn't, the pass doesn't mean there's toxin. The test not passing means what?
The test not passing means that maybe our pipetting skills, so the way that we put the water into the wells maybe wasn't accurate enough, or maybe there was a sample that splashed from one well to another by accident. And sometimes we don't even know why they might fail, but they just do. And we have to start them over because we want to make sure that our data is 100% reliable and absolutely correct. Going back to that excellence that you mentioned, we would never put out toxin results that came from a failed test. So anytime that we fail a test, which it wasn't too many times during the summer, but it does definitely throw a wrench in things, we will immediately go back and retest, but like I said, from step one. So we really pride ourselves in the time and effort that we put in to all the aspects of our lab, but specifically our toxin tests. not only myself, but my student interns that work during the summertime, they put in a lot of time and effort and training into these tests in particular. Even like during the semester before the summer, so spring semester, I'll start to prep students, and I have someone upstairs right now that's working this summer, and I just actually had him start practicing pipetting now. So in preparation for the summertime and in preparation for the data that will be going out to the public, we want to strive for that excellence and start practicing now so that we can ensure that our data will be the best that it can through our training. And it's just a lot of, like I said, time and resources. And if we can ensure that a test won't fail by a lot of hours of training, then we will do that. I will do that. So again, we strive for excellence, especially this data that's going to the public.
Yeah, a couple more things I'll mention. What Anna's able to do with her team is we also have a quality assurance protocol that we get approved by the Indiana Department of Environmental Management. In the state of Indiana, really the Lilly Center for Lakes and Streams and what we call IDEM are the two sort of leaders in doing this sort of toxin testing in the state of Indiana. And so they actually certify the protocols that we use here at the Lilly Center. And so that's a big part of what we do. We also will do some independent samples where we send them some of our samples down in Indianapolis, and they send us some of their samples, and we compare our results that way. And then a third thing that we do, which is kind of, again, on this quality assurance idea, is we will actually get unknown samples from the manufacturer of these test kits. And we do what's called proficiency testing, right? And we'll have yourself and maybe one or two of your students go through the proficiency testing process as well. And so not only the test itself could pass or fail based on the precision of our work, but we have all of these other things in place to make sure that those toxin results that are going out to the public are extremely accurate and precise, because it has to do with people's health and the health of their pets. And so we take it really seriously.
So Anna, tell us about your first week of 2025 when you are now leading this.
Yeah, it was a crazy week. The weather was pretty bad. It was very cold, super windy, and that made sampling just be delayed. So usually we have all of our samples come in on a Wednesday, but we didn't get some of our samples until halfway through the day on Thursday. So that postponed all of our toxin testing, and we had to wait to do freeze thaws until halfway through the day, which already put us 4 hours behind where we needed to be. And our first sample, or our first test actually failed, so we had to rerun that. So that was another 4 hours into the evening that we were working.
Just for the freeze and thaw, right?
For the sampling, for the toxin sampling, but yes, for the freeze thaw too. So I think Hallie, my team lead, and I stayed really late that night. Around 10 o'clock in the evening is when we got everything wrapped up. Thank the Lord, our second toxin test passed. But it was pretty stressful. We didn't think we were going to get the toxin notification out that following morning. So we were preparing to have to, send an email. Hey, guys, sorry about that. Maybe on Saturday or Sunday. But we were able to get it out. And I was very proud of my team. It was definitely a learning experience, being my first week of actually doing a toxin test. But it was, like I said, it was a learning experience, and really rewarding afterwards, knowing that we did that. We got it done. Just barely, but we got it done. So the following day, I took my team during our lunch. We went to the animal shelter down the street and walked some dogs and played with some cats as a reward, and they loved it.
Great. I remember that summer. That was really cold spring.
Yeah. Yes, very.
So, Nate, all of this work that's being done to identify toxins.
Yes.
Tell us about the blue-green algae toxin.
Yeah. So when we talk about algae toxins, we're talking about those toxins that are produced by a specific category of algae, which we call blue-green algae. More technically, they're known as cyanobacteria. It's actually a bacteria that can also do photosynthesis. And so they're kind of this weird category of kind of bacteria, but kind of algae. And so that's why we have some different names that we call them, but they will produce these toxins. So there's a connection then with how much algae you have in the lake, this specific type of algae, and how many toxins you might have. So visually, if you've got lots of blue-green algae in the lake, and this algae is often going to look kind of like green paint in the or pea soup, some people will call it, where the water itself has this green color, a little bit of an oily sheen potentially to it. If you put a stick in it and lift the stick up out of the water, there's not going to be any filaments hanging on that if it's blue-green or cyanobacteria. And so visually, often there's a cue for the lake user that there's a problem there, but not always. Sometimes there's a mismatch between how much blue-green algae is in the water and how much toxin that blue-green algae may or may not be producing. We think it has something to do with picoplankton, which maybe Anna will talk about a little bit, which is the tiniest type of these particular algae. But sometimes just relatively few algae can produce a lot of toxin. And other times there's lots of algae there that could produce the toxin, but they're not producing it for whatever reason, which makes the toxin notifications that we do every week all the more important for our local residents and visitors.
So tell us about the type of plankton Nate just described.
Yes. We, looking at one of our lakes, so Wabi Lake in our county, 2 summers ago, we noticed this trend of it having really, really high microcystin levels, but the water clarity was very high as well. So very clear waters. I mean, I went to Wabi Beach many times, and up to your neck, you can see your toes sometimes. So it really just didn't make sense to us, because usually when we see high toxin levels, we also see a very murky lake, but that just wasn't the case here. So my lab, my team, we took a deeper dive into the samples that we received from that summer, and we realized that there were really, really high values of the picoplankton that Dr. Bosch had mentioned, and not so much of the bigger algae that might release those toxins. But the picoplankton that we were seeing do have the capability to release microcystin, the toxin that we test for weekly. So that was very eye-opening to us for sure, because it's just not something that we would see normally, I would say. It may not be unique to that lake. We may see that trend in other lakes as well, but specifically Wabi was a very good example of these teeny tiny small algae that some labs may just write off as nothing. But we like to take a very close look at those types of algae, because they're obviously making a big difference in the environment.
So you noticed it 1 year. You said like 2 years ago. Did that carry through last year?
Yeah, that's a great question. We're still working through some of our 2025 samples right now. So usually during the school year is when we'll do most of our counting from the summertime. So I won't say exactly yet, but it may very well be the same trend, but I'm not sure yet. We'll see.
So I think it's important here to point out the difference. So we were talking about the toxin analysis, right? Which is the microcystin, the chemical that these blue-green algae or cyanobacteria can produce in the water.
They release it when they get angry.
Yes, when they get angry, right? Which is the health concern. But those are coming from these blue-green algae cells themselves. And as I said, sometimes there's a mismatch. So when Anna talks about catching up on samples, we're catching up on those algae quantification and identification samples, not the toxins. The toxins are what we do every week to keep people safe. But then we want to compare it to what was there, what type of algae, how many of them were there, so that we can try to understand more why toxins are being produced at some times and not others. And so their team is going back through previously collected data, and we have some pretty sophisticated microscopes to be able to see all the way to those tiny little picoplankton, which is why a lot of research labs around the country probably ignore those. Because they are so tiny and hard to see.
For sure.
I know I've gotten to see your sophisticated microscopes. If somebody wanted to learn more about what's happening here, can they come visit the research team?
Yes,
can they come visit the center?
We love giving tours.
We do.
And Anna is one of our best tour guides on our
Thanks.
staff. So people are really intrigued to go up there, see all the sophisticated equipment, but even more so start to meet some of the people up there because Anna has a wonderful personality and is really passionate about the research work that we do up in the lab, but she also has the team of students that are equally passionate about it. And they're learning to communicate about, the research that they're doing and being able to describe that to other people who come and visit.
Anna, processes improve over time. Tell us about what you're doing with the data that you're collecting.
Specifically for our algae program, we are constantly improving the way that we're counting and our identification of algae. When I first started as a student, we spent a lot of time on all algae. And over the years, we've really narrowed it down to specifically cyanobacteria that we're focusing on. I like to say that we specialize in cyanobacteria because we really do. So a lot of time and effort that was being put on algae that don't release toxins. We still classify it, but we don't spend nearly as many hours as we used to, specifically finding genuses for that algae. So now my students are specifically identifying cyanobacteria, and we put a lot of time and effort into that, yes, but that has cut down our counting time by more than half now that we have been doing that, and we've set that as a protocol.
Because that's the dangerous algae.
Yes, that is the dangerous algae. That's the algae that
Cyanobacteria.
releases the toxins. That's the algae that we care about.
And it's not only identifying those algae, but also quantifying.
Yes.
And your protocols have continually improved in the quantification as well, looking at natural units versus just number of cells in the water.
Yes. Yep.
In pursuing excellence here, what's your vision for the future?
Oh man. I see a lot of growth, specifically with our E. coli program. There is a lot of potential there. There's a lot of ways that we can serve our community, whether that's through water testing or even personal lake testing in the future, not now. But there's a lot of certifications that we can receive from the health department beyond what we have right now, that we can better equip ourselves to test for certain types of E. coli in our lakes, trying to figure out where it's coming from, whether that's from humans or animals, cattle. Birds too. Yes. Oh yes, very much. But that program in particular is very exciting to me, and one that I've spent a lot of time on this past year just to ensure that we're meeting our standards and we are performing well based on the health department standards. Our auditor, Katie, she works for the health department. She comes and visits us once a year. And every single year she comes, she is always very impressed with our lab.
And that's the State Department.
That is
of
the
Health.
State Department,
Yeah.
yes, which is really awesome for our little lab and the way that we're able to upkeep that program in particular. And specifically, pretty much our entire E. coli program, besides like the administrative portion of it, that's my job. But it's mostly run by college students, and they are upholding that standard of excellence that the health department recognizes and the health department is impressed with. So I'm really excited for that in particular, to just be able to broaden our scope and just our research in that portion for sure. And then just as a public service as well.
Yeah, so let's talk a little bit more about that E. coli that you brought up. So you've got some things here in front of us for those who are viewing on YouTube.
Yeah,
those of you who are doing more of the audio listening, maybe you want to switch over and watch this episode on YouTube. But E. coli is another human health concern in our local lakes. And so that's why we sample E. coli. So tell us a little bit about how you guys do that.
Yeah, so the field team, again, they take samples in this bottle here. And then they bring that back up to the lab. The lab adds mostly students, mostly students add a reagent to our sample. And then if there is E. coli in that sample, the reagent will bind to the E. coli. And after an incubation period, it will glow under UV light, which is always fun to train and show them because they're looking through the UV light like, whoa, that's so cool. Well, it's not. It's E. coli. It's gross. But right here, so I don't have a UV light with me, and I wasn't going to bring one down with me. But we're looking specifically for E. coli and coliforms. So all of the yellow wells here are positive for coliforms. That's just coliforms is another word for bacteria. And then we mark those with the little line down the center here. And the ones that had the little cross, so I think there was just the 2 wells here were positive for E. coli. So that's actually really low for a stream. And with the cold weather, that's pretty normal. Usually it's during the summertime that we see higher levels. So with the freezing temperatures and all of the snow lately, that makes a lot of sense. But this is one of our trays, and based on the number of yellow wells and the number of glowing fluorescing wells, we can get an actual number of what we call colony forming units. So that puts the amount of E. coli in the sample as a value. So and the value here would be 2 colony forming units.
And also the sample bottles, this one is clear for E. coli, whereas our microcystin, the algae toxin, is an amber bottle because in the field, when you're collecting those samples, the sunlight can actually start to break down that microcystin almost immediately. And so we have to keep it protected from sunlight with that amber color bottle.
How long after you put water in those sample bottles does it take to get to your lab?
It depends. Usually E. coli will come back to us within 4 hours, but usually the field team will take multiple samples, throw everything in a cooler, and then bring it back to us.
So they keep it in a temperature controlled.
Yes, they do. They're very good at that.
Your eyes sparkle when you tell us about the students that you get to work with on your team. How is managing students? How are you finding that?
I love it most days. I love seeing them come in, and I think they like me. I hope they like me. But they come in and they always have something to tell me. I have a few students, they'll come in the lab and they're like, Anna, guess what? And I get to hear about their day and what's going on in their classes. And I really love to hear about their plans after college. I love that so much. I love to hear their dreams and like getting one of my students, her name is Abby. She's going into, she wants to be a physician's assistant, and she's been applying to all of these programs, and she got into one at Cedarville. And it's just like that shared joy. I'm able to just be happy for her accomplishments and my other students' accomplishments as well. Hallie, who I talked about earlier, she's trying to get into a medical lab to do medical lab testing at, I think, Parkview here in Warsaw. But she has an interview on Tuesday with Parkview. So I'm really hoping and praying that she's accepted in their program. But it's just being able to appreciate their college journeys, because I'm done with mine, but it's so fun to hear about theirs and just celebrate with them. It's a lot of fun.
So as they're doing this research and learning how to do research, what other careers might your students be pursuing?
So right now I have 10 student interns. I only have one that's actually environmental science. And usually I have a lot of pre-med and biology students that will work upstairs, specifically with their pathway. They're looking to go to grad school, and any lab work and research always looks awesome on a resume. And they're the ones that are very dedicated, and they're like ready to go to grad school, and they're ride or die, like in the lab all the time. And I love that about them. Let's see. I do have one psychology student, but he is a minor in biology. And he actually worked with us this past summer. And it's been, like I said earlier, it's been such a joy to just see his college journey and his major change, and just being able to be joyful for him in that. But also having that love of science. Not only is the lab experience good for any of their resumes, it's just really cool to give them the experience. And even like going back to our E. coli program, that's all through the health department. And these people who are on a pre-med track or a health track, they're able to put this on their resume as like a service to the general public through the health department. And that always looks great. Like they get certified with this through our program, which is then through the health department. So preparing them in that way is really cool.
But you're wearing another hat as well as a graduate of Grace and managing your team here. What else are you doing? Master's?
I am doing my master's. Oh my goodness. I was like, what are we getting to? Yes. I took a little bit of a break this session. I got married this past summer, and having a new job and doing a master's program, it was kind of a lot. So I took a small break this session, but I'm finishing it up at the end of next year, which I'm very excited about. But yeah, I'm getting my master's in nonprofit management. It's actually kind of a long story. I started it when I was going to school here, and I feel like I kind of was just taking the classes because a friend of mine was doing it. I was like, yeah, I'll do it with you. Why not? But now that I'm in this position as a coordinator at a nonprofit, I'm able to appreciate my classwork so much more. And my advisor, so Professor Grill, I forget his first name, Steve Grill. Yeah, he's been such a mentor to me. And it's all online, so a lot of students are maybe even out of state, but I'm able to meet with him like in person and talk with him in person. And it's been so nice to have like a mentor in that. And I'm just so thankful for that opportunity through Grace and through my job, and just being able to appreciate it so much more in my professional career rather than my undergrad career. So yes, I'm very excited about that. I can't believe it. I didn't pick on that.
I'd love to talk more about some of the students and what they're being prepared to do that work here at the Lilly Center. But before we get there, I did want to come back to just sort of Anna's journey a little bit, because I got to see it from a different vantage point as her professor. And it was so much fun to see God working in her life as she was sort of figuring out what would be a good career path. And early on, it was nursing.
It was.
Right? And then, but you took that science and that desire to help people and moved it into an environmental science field, and how you can help people as we care for the environment around us. And that time in the laboratory even allowed you to meet your husband, right? So tell us about that, and then I'll talk a little bit more about other students.
Yeah. So I started working at the Lilly Center probably my second week into my freshman year. And at that point, I was switching to nursing. And I was working with my husband too at that point. So he was working at the Lilly Center when I started.
But he wasn't your husband yet, right?
No, he was not my husband yet. He was a stranger. I didn't know who he was. But we worked together.
A little lab chemistry.
We did have a little lab chemistry. We did. Yeah, we kind of just worked as coworkers for the first year. And then my second year, I was working as a lab TA for anatomy and physiology. And so was he. So we were like seeing each other then, became friends then. And then that following summer, we worked together at the Lilly Center as college interns here. And we got to know each other a little more and like spent more time together. And then we started dating. And he proposed to me the fall of my senior year. And then we got married just this past June. So I am so thankful for my husband and my job that let me meet my husband. But yeah, it's been a lot of fun. He has a lot of very fond memories. He worked specifically with E.coli when he was a student. He kind of, in a way, kind of set that program up.
He did.
He really did.
He worked hard at that.
Yeah, he did.
And was able to get us in the position where we could initially get certified by the Indiana State Department of Health. And then now it's kind of fun. You are continuing on with staying certified, and that might be even a little pressure at home.
I was
like,
I was going to say that when I first started.
Don't mess up the certification.
Oh my gosh.
I worked so hard.
I was so scared. I was like filling some big shoes, like trying to figure this out and just picking up the pieces. And oh man, the amount of times he actually came in so many times my first couple months and was like helping me figure out what the heck I was supposed to do for the certification portion. Running the test is one thing. That's easy. But keeping up with all the paperwork and making sure that I'm taking all the correct temperatures, and it's like daily stuff I have to keep up with. So that was That was nerve-wracking, but he was a lot of help. And now I feel like I'm at a spot where I don't have to ask him questions anymore. I think I'm more of an expert than he is.
Good.
Don't tell him that.
I think that's such a good example, though, of our students that are here at Grace College working at the Lilly Center for Lakes and Streams. Right now, we have 46 such college student interns working here at the Lilly Center. And just like we were talking about Connor and his now husband, he was able to show great leadership and individual initiative to be able to move us in this new direction as a lab. And it was always being overseen by a regular staff member, and so it was done with great quality, but he had strong initiative, and that then built his resume for him now to work in an analytical laboratory at a wastewater treatment plant for his job. And so we've had a number of students prepared well. And so maybe 3 categories quickly of students and where they go. One would be for government agencies. So we've had students go to federal, state, county, and city level governments doing different things with water, whether it's wastewater or drinking water or surface water out in the environment. We've also had students go into a for-profit industry. So maybe it's environmental consulting, maybe it's environmental law, maybe it's working for a lake management company. Maybe it's going to work in agriculture, whether it's more conventional agriculture or more organic or hydroponics or horticulture. We've had students go on into nonprofit organizations. Anna mentioned that she's pursuing a nonprofit master's here. And so we've had a number of other students go through that program and are now working in nonprofits in different parts of the country, some with water, some not with water, but many working with different environmental sort of fields in the nonprofit sector. And so it's really fun to see students grow and mature, build their resume, and then go out and get wonderful careers even after they leave. We look at that as a multiplier of the Lilly Center for Lakes and Streams. These students come in, they have an impact, they're helping our local lakes and streams, but even after they graduate, they continue to have an impact in whatever place that they end up working in.
And they have impact on our local public school students.
Yeah, we've had a number of students that have gone into education themselves after graduating, but we also have a number of those 46 interns are working with K-12 educational programs that we have here at the Lilly Center, building up water literacy in our local citizens.
The aquariums in the classrooms.
Mm-hmm. Yep.
Lakes in the libraries.
Mm-hmm.
And what is the program where you entertain students when they have an opportunity to fish?
Oh, our field day.
Do you participate in field day, Anna?
No, I do not. I don't get to participate in the fun stuff like that.
Remember how she was saying that there's so many samples in the summer, they spend the whole school year trying to catch up. Yeah.
I'm a little busy.
Anna Frentzel, thank you so much for being here today. And thanks for the joy that you are bringing to the laboratory and connecting with your students, your team members. We just wish you much, much success in the future and hope your vision for the future here comes to fruition. Thank you
so much. Thank you. Thank you.
Thanks for listening to this episode of the Lake Doctor Podcast. You can share your thoughts or submit questions by leaving a comment or sending an email to lakes@grace.edu.
Listening to this podcast is just the first step to making your lake cleaner and healthier. Visit lakes.grace.edu for more information about our applied research and discover some tangible ways you can make a difference on your lake.
We'll see you next time. The doctor is in.